I just finished up my playoff model and I'm excited to show you guys the results. So let's just get right into it. So first, again, I got all of my data from profootballreference.com. You can see the data I used if you just go right here to where it says teams and then you go to any team like Buffalo Bills. It'll show you right here, and for the second half of my model, I'm pulling the data from right here where it says schedule and game results, where it shows you the box scores and statistics for every single game that a certain team played every week. So if you go right here, it shows you the box scores for every single game that this team played during the season. And I just pulled that. And I pulled that for every single team that was here. Took a little bit of time. And then let me show you my script. And then once I had saved that to my desktop, I wrote this script and I ran it. I'll make all this code available online on my GitHub so you guys can see it. But I just pulled in all the data over here where I saved it to game data. And pretty much I just brought in the data. I cropped out all the junk because there was a lot of junk in the file. I renamed the columns to something that was more readable and more usable. And then all of this is more formatting, just converting columns. Some columns need to be converted. For instance, this one, for the win or loss column, instead of saying W or L, I put 1 or 0. This column was ultimately dropped anyway. Home, instead of having an @ sign or away, I put home or away, 1 for home, 0 for away. And that was pretty much it for that. Saved it all to one file. And then secondly, the main part of this is I added in my results for the first model. So let me take a step back. In order to create this second version, I used the model from the first version. If you watched my first video, you saw that I had already set up a Super Bowl prediction model. I ran it last year, and I actually used that same model again this year with the stats from this season. But instead of using this model, I actually just use the outputs of these model as a feature in this other model that I just developed. So if you'll remember, sorry, that's the wrong one. If you remember, for my first video, I brought you through this script, which is my decision tree model, and it outputs, skimming through this, it outputs a probability that a team will win the Super Bowl for this season. So for this particular version of the model, the Saints, the Buffalo Bills, and the Kansas City Chiefs had the highest probability for this. I believe this is the logistic regression model that I used. So I actually put this column, the prediction, as a variable in my next model as a likelihood score that they're going to win the Super Bowl. So this was one of the features that was used in my next model. And that's how I really expanded to this original project that I had. I actually used this whole output. And the feature that it gives out is pretty much a feature that shows how likely a team is to win the Super Bowl based on their season statistics compared to the season statistics for teams that have won the Super Bowl in past years. So this variable, I really like it because it has a sort of historical component, and it shows how these teams rank up to previous Super Bowl winners. So for that, I call it my Super Bowl prediction variable. I have a version that was run with Adaboost and another one that was run with a logistic regression. I think the logistic regression was ultimately better. It was a better indicator of a team that was more likely to win the Super Bowl. So when I'm actually running the model, it actually did show that the logarithmic version of this variable is actually more important than the Adaboost one. And then after we added that variable in, I normalized it just for my own purposes. I didn't put the normalized version into the model. It does get scaled when the rest of the data gets scaled, but for this part where I'm actually putting a normalized version in, that's just for me to view. It gets taken out later. And then this is more just data cleaning. And this is the area where I'm actually putting in the results of my first model to the complete data. And then I go ahead and I write that out, and now I have my data set. So let me give you a glimpse at the data that I'm using. Now that I've pulled this data and I've merged it all together, you can see that it's the team abbreviation, I have the full team name, I have the week of the game that they played, the opponent, and I have how much they scored, how much the team scored. All the game statistics are right here, and I also have the Super Bowl likelihood indicator that I just talked about, the Adaboost version, and the logistic regression version. So, few things here. What I'm actually using as my target variable right here is team score, the amount of points that the team scored in that game. So on the moving forward, this is going to be the amount of points predicted that the team will score in that playoff game. So I'm using this as the prediction variable, and I'm running the model for one team. Let's say if I was doing it for this week, I would run the model on the New York Jets to see how many points they would score against the Buffalo Bills. Then I would run the model again, inputting the Buffalo Bills to see how many points they would score on the New York Jets. And the team, obviously, that's projected to score the higher amount of points is the winner. Makes sense? Cool. Okay, so let me get into the first version of the model. I actually made 3 versions with 3 different models. This one is a random forest. Then I used a boosting algorithm, and the other one is a multi-layer perceptron. So the first one I did was my random forest model. I did it first because random forest is probably very quick to set up. You don't even need to standardize or normalize the data. You don't need to convert any of the categorical variables. It's quick, it's easy, boom. So right here, just importing all the data. A few things taking out of the data that I don't want to use in the prediction, obviously. The team, the abbreviation name, the week, how much the opponent scored, because when I'm predicting for the playoffs, obviously I'm not going to know how much the opponent scored because the game hasn't happened yet. And the result, because obviously that gives away what the score would be. And the result is what we're trying to predict, obviously. So these are the season statistics, the actual game stats. And the way that I set up this model is I took every game stat for the season and multiplied it by 16 to show what their game stats would be if they got those numbers every game for 16 games. So it's kind of an estimator of what the season statistics would be. That might be a little confusing right now why I'm doing this, but the reason that I'm doing that is to get a sense of how each statistics affect the score, because when I'm actually using the prediction, when I'm actually predicting the score for the playoff games, obviously I'm not going to know the game statistics for that game because it hasn't happened yet. So the only thing I can use is statistics for, let's say, like the previous 4 games. So I'm going to have to predict on those, the previous 4 games leading up to the playoff game, and then I'll use a multiplier to convert those into season statistics so that the training data and the test data is on the same scale. So I hope that made sense, but it's necessary for the model to learn the correct information. So it's necessary for the model to learn the relationship between these statistics and the score in order to create the predictions for the playoffs, because the game data for the playoffs that I'm predicting on, obviously it hasn't happened yet because the game hasn't happened yet. So that's how I approach this. You can see a little shot of the data right here. As you can see, no need to normalize or standardize. I actually did use dummy variables for this, even though it's not necessary for a random forest. I just put it in there because it's good practice. Here's my actual modeling component. All of these models were used with scikit-learn. I broke it down into training and test data using train test split right here. Once again, I'll make all this code available for you guys so you can see it, go through it. I made my test size very small because the amount of training data was already very small. So so I wanted to be as much data as possible into the model, because honestly the I mean, we can score the model on the test set, but really, really we want to use as much data as possible to make the model as good as it can be for when we're actually predicting the playoffs. So when I tested this on my test data, for this model, I use mean absolute percent error because it's something just very understandable. So of all the scores in the testing data, every time I predicted a score, it was off by an average of about 5.2 points. And then right here is where I actually created my score predictor. This is the most important thing. This is how I actually predicted the score. This is the most important thing. This is where I actually predicted the score. So my function, it takes the two arguments, the home team and the away team. The home team has a slighter advantage from what I've seen. I didn't put in that it had an advantage, but that's part of the data that was put in. So it learned that teams that are home usually have a slight advantage, usually score more points. So this function pretty much takes all the data. It selects the data from our large data set. We're only the two teams that we specified, so it's a head-to-head matchup. And it takes, for this particular version, I took games 11 to 16. So this is an indexing slice. So obviously 0 is game 1, 2 is game 2. So this actually goes from, game 11 to game 16. And it takes the average of that, the average statistics from those games to use as an input for the model. So team 1, the past 6 games they played, that's going to be the data that it's used to predict on. Team 2, same thing. And right here to make it an ultimate head matchup, the training data, as you can see here, it's trained on how many first downs, how many offensive scores they get, these offensive statistics right here and these defensive statistics. So if it's a head-to-head matchup, then for team 1, we keep the offensive statistics. And then for the defensive statistics, we take the offensive statistics for the team that they are playing to make it a true head-to-head matchup. And my whole model is built around this, the whole head-to-head matchup. How many points will this team score when playing this other team, pretty much. So this is really a head-to-head matchup model. Echoes that, and then it just predicts right here, and then it shows you who will win the game and how many points each team will score. So I already ran this model. Here's the output right here. Here's my random forest. And let's get into the fun stuff now. Round 1. So I'm going to be doing this a round at a time. For those who are here on TikTok, from my TikTok, I'm doing this a round at a time. So right here is the first round. So the first team that's mentioned is going to be the away team, and the second team is the home team. So it's Indianapolis Colts at Buffalo Bills. Look at this game right here. Every time I rerun the model, oh man, this was a close game. But right here, predicted Buffalo Bills will win by 2.3 points. Both of these really good teams. This game is probably going to be very close. Second one, Baltimore Ravens, Tennessee Titans. Another very good game, but to a lot of people's surprise, this model has the Baltimore Ravens coming on top. A pretty close game again, 28.4 to 26.2. This is going to be a very good game too. Several other models I ran had the Titans above them, and several other models I had the Colts above the Bills. Very close games. Now this one might surprise a lot of people, but in my mind it's not really a surprise. The Browns just beat the Steelers. They've been a great team. Steelers have been kind of getting exposed the past few weeks, so this model says Browns on top 27.9 to 24.2. Another very interesting game. Now to the NFC division rivalry right here. Seahawks, Rams. Seahawks ahead by about 3 points, 21.4 to 18.8. Now this game, a lot of the models had run. It was a bit of a blowout, but yeah, Tampa Bay Buccaneers about 10-point favorites to the Washington football team. Even though the Washington football team's at home, I mean, Tampa Bay's just been a lot better. We'll see how Chase Young does against Tom Brady. He wanted to sack him, so we'll see. But Tampa Bay by 10 for this one. Chicago Bears at New Orleans Saints. This is a surprise. This is a surprise because I know the Bears have been doing well the past few weeks, but Chicago Bears 27.8, New Orleans Saints 25.7. That is a surprise, is it not? We'll see if it happens. You know, maybe the model knows something we don't. The Bears have come on late. They're only 8-8. And the Saints are a very strong team, but you know what? Upsets happen every single week in the NFL. So let's see. This one also another big upset. Baltimore Ravens, Kansas City Chiefs. The Chiefs have been the team the Ravens could never get through. Model is saying that is going to happen this time. Kansas City Chiefs 23 to the Baltimore Ravens 30.2. And this one, Browns, Buffalo Bills. Cleveland Browns score a lot of points, 29.3. Buffalo Bills, too much for them, 32.6. And then in the NFC for the second round, Tampa Bay Buccaneers at Green Bay Packers. This is a battle. There's two of the all-time greats of the quarterback position. Tampa Bay Buccaneers says 28.3. Green Bay Packers 27.8. High-scoring game, very close, a lot of firepower, but Buccaneers ultimately pull it out. And this one, Chicago Bears at Seattle Seahawks. So the Bears that are going on a little bit of a run over here. Chicago Bears 25.5 and Seahawks 23.5. Now AFC Championship game. Baltimore Ravens, Buffalo Bills. I got the Bills by 1 point. Two very good teams, 30.2 to 31.5. Buffalo Bills take this one. And then Chicago Bears, Tampa Bay Buccaneers. Tampa Bay Buccaneers finally put a stop to the Bears' run. Tampa Bay wins pretty comfortably, 34 to about 27.4. And the Super Bowl, for the Super Bowl prediction, I took the home team factor out of it. So both of these teams were not influenced by whether or not they were the home team because the Super Bowl is at a neutral site. Tampa Bay at Buffalo Bills. Buffalo Bills by 0.8 points. 0.8 points. Very close game. I do hope that's the Super Bowl. That's a great game. Now, you've already seen this. This is my boosting model, actually. Same pre-processing, same everything, except I had to standardize the data in the model. Dummy variables and data standardized right here. Same exact modeling, same exact modeling, same exact score predicting function. Let's get into the results. First game, Indianapolis Colts and Buffalo Bills. Colts are the winners. This game has always been close. No matter what route I'm on, it was close. This one, the Colts pull it out, 30.8, 29.7. Next one, Titans, Ravens, 29.3 to 28.3. Titans pull this out. Very close games, man. These could go either way. This one, Cleveland Browns, Steelers. Cleveland Browns again. This one by a whole touchdown, 30.3, 23.1. And again, now back to the NFC, Now back to the NFC. Los Angeles Rams, Seattle Seahawks. Again, Seattle Seahawks ahead pretty comfortably by 9 points, 12.8 to 21.0. The Rams can struggle to score at times, so I understand that. Tampa Bay Buccaneers versus Washington football team. This one, Tampa Bay ahead by a lot, by 14 points. Chicago Bears at New Orleans Saints. No run for Chicago in this model. New Orleans wins 27.2 to 26.9, but it is a close game, so these models are predicting that Chicago Bears has a lot to offer in these playoffs. Now, round two. This one, again, a lot of these models do not like the Kansas City Chiefs for some reason, but right here it says Tennessee Titans 29.3, Kansas City Chiefs 23.8. First round elimination again for the Chiefs. Next one, Cleveland Browns Colts. The Colts win 30.9 to 30.1. Very good showing for the Browns, but Colts ultimately take it. Now in the NFC, Tampa Bay versus Green Bay. This time, Green Bay takes it 33 to 27.4. So the Random Forest had Tampa Bay taking this one. This one has Green Bay on top. Next, Seattle Seahawks versus New Orleans Saints. Seattle 20.4, Saints 26.2. New Orleans is going on to the NFC Championship. This will be a good game too right here if it happens. Colts versus Titans. Ooh, it's too heavy it is right there. Colts 29.8, Titans 33.3. Titans are the winners. I could definitely see the Titans going on a run. I mean, their defense is all right. It's not as good as last season, but it's definitely all right. And with Derrick Henry, A.J. Brown, Tannehill, Corey Davis, Jonnu, I mean, they have a lot of weapons. And they're built for the playoffs. They could really go far. Colts are built for the playoffs, two very similar builds, but Tennessee pulls it out this one by about 4 points. NFC Championship, New Orleans Saints, Green Bay Packers. New Orleans Saints 29.9, Green Bay Packers 30, so they won by 0.1 points. 0.1 points. This was predicted. And Super Bowl, again, no home field advantage. Tennessee Titans, Green Bay Packers. Green Bay Packers take it by 0.1 points. Two back-to-back games, 0.1 points predicted. Tennessee Titans put up a good fight but fall short. And last but not least, this is my multi-layer perception model. The training is a lot different because it's a deep learning model, so I had to specify a lot of things like the hidden layer size, number of match iterations before conversions, the batch size, the solver, and the activation function. I played around with these parameters a lot. I ultimately used a grid search algorithm, but that ended up crashing, so I ended up just playing around with these parameters manually. This one had mean average error of 4.68 points, so it was actually the smallest of the bunch, I believe. Let me go back here. 5.4, so yeah, the smallest of the bunch. However, that doesn't mean that much in this certain scenario. And let's get to the results. So this one has Colts losing to the Buffalo Bills 30.1 to 26.1. Bills will take it out. Ravens over the Tennessee Titans 28.1 over 25.3. And then this one, finally the Pittsburgh Steelers get a dub, 24.7 and 29.3. Steelers take it. Next up, nothing new here. There were a few models that had the Rams on top, but ultimately when I finalized everything and the parameters and the data that I wanted to, the Seattle Seahawks always won in any model that I use. So Seattle 26, Rams 22.5. This one, again, Tampa Bay above Washington. And then this one, no run for the Bears again. It's Saints 28.3, Chicago Bears 23.6. Round 2, Kansas City Chiefs finally with the win. It's a model finally like the Kansas City Chiefs. Baltimore Ravens 25.4, Kansas City Chiefs 26.3. Next, Pittsburgh Steelers versus Buffalo Bills. This could be a very good game right here, but Buffalo Bills pulls it out 29.8 to 26.4. Another close game decided by a field goal. Now to the AFC of round 2. Tampa Bay Buccaneers at Green Bay Packers. Tampa Bay will score 28.7 and Green Bay will score 32.6. Green Bay ultimately pulls it off. And then Seattle Seahawks at New Orleans Saints. Seahawks 27.6, Saints 26.5. Seattle narrowly escaping with a victory right there. Now round 3, AFC and NFC championships. Buffalo Bills versus Kansas City Chiefs. Kansas City Chiefs beat the Buffalo Bills 29.4 to 28.1. Got Andy Reid going to 3 straight AFC championship games and back-to-back Super Bowls. And then for the NFC championship game, we have the Seattle Seahawks versus Green Bay Packers. Seattle Seahawks 27.2 to Green Bay's 29.8. Green Bay wins that one and go on to the Super Bowl, where it's Green Bay Packers versus Kansas City Chiefs. Green Bay narrowly pulls it out again by 1.5 points. Green Bay Packers 30.5, Kansas City Chiefs 29. So those are my results. I actually showed you guys the entire results, even though at the end of round 1, I'm going to run it for round 2, and then rerun it for round 3, the NFC and AFC championships, and then finally again for the Super Bowl. And I will be putting those on TikTok, so follow me on TikTok. I'll leave that in the description. But if you have any more questions or comments, feel free to comment. Let me know what you think. Tell me what model you think is going to do the best. Tell me what your personal predictions are. Tell me where you think the model completely screwed up. I would love to know everything. Thanks for watching this. There will be a lot more sports modeling to come because I love doing this. And we'll see. I'm actually going to put these online. I'm going to put these into a bracket and see which model does the best. And I'm also going to enter my own predictions and see, can I actually beat these models? If it's my guess, I think the boosting model does the best, but hey, you never know. And we will see how that works out. We'll see how my personal predictions work. So thanks, and I'll talk to you guys later.